Have you ever wondered what the future of manufacturing might look like in space? A question that sparks both curiosity and wonder, as it opens up a whole new realm of possibilities. Space manufacturing, as we currently understand it, is limited by a variety of factors. The most obvious one being the sheer cost and logistical challenges of sending anything into space. It's not just about the materials themselves, but the equipment needed to work with them. This isn't a simple process, it's a complex and expensive endeavor that requires meticulous planning and execution. Now, think about the sheer volume of materials needed for long-term space missions or for building structures on other planets. We're talking about tons of material, all of which needs to be launched from Earth, a process that is both costly and resource-intensive. It's clear that this model is not sustainable in the long run. But what if we could change all that? What if we could bypass these challenges and create a more effective, efficient way of manufacturing in space? Enter the world of 3D printing, a technology that has already revolutionized manufacturing here on Earth. 3D printing, or additive manufacturing, allows us to create complex structures layer by layer, using a variety of materials. This technology is not just a game changer, it's a potential space game winner. With 3D printing, we could potentially send compact printers into space, which can then use readily available materials to create whatever we need. This could range from spare parts for spacecraft, to habitats for astronauts, to scientific equipment for research. The possibilities are virtually endless. This isn't just a pipe dream, it's a tangible possibility. In fact, there are already experiments underway to understand how 3D printing can be used in a zero-gravity environment. Imagine a world where we could manufacture directly in space, bypassing these challenges. That's where 3D printing comes in. As we step into the future, the vision of space manufacturing is shifting, and 3D printing is leading the charge. 3D printing isn't a new concept. It has been evolving for decades now, transforming various industries on Earth. The genesis of this technology can be traced back to the 1980s when it was known as rapid prototyping. The initial goal was simple: to create physical models quickly and cheaply for design purposes. It was a tool for visualization, a way to bring two-dimensional ideas into the three-dimensional world. As the technology improved, the 90s ushered in a new era of additive manufacturing. Instead of merely creating prototypes, 3D printing began to produce final products. This was a game changer, as it allowed for the customization of parts, even in small quantities. Industries from automotive to medical saw the benefits of this new manufacturing approach, as it allowed for greater flexibility and customization. But the real revolution in 3D printing came in the 21st century, with the advent of new materials and improved precision. Nowadays, we're not just talking about plastic models. We're talking about 3D printed houses, 3D printed food, and even 3D printed organs. It's astounding how far we've come. Speed, too, has seen significant improvements. What used to take days or weeks can now be accomplished in mere hours. The variety of materials used in 3D printing has also expanded exponentially. We've moved beyond plastics and resins to include metals, ceramics, and even biological materials. This expansion has opened up new possibilities and applications for 3D printing, making it an integral part of our everyday lives. The evolution of 3D printing is a testament to human ingenuity and our relentless pursuit of innovation. It embodies our desire to create, to build, and to make the impossible possible. But as we stand on the precipice of a new era, we must look to the stars. As impressive as these applications are on Earth, the potential for 3D printing in space is even more exciting. So, how does 3D printing work in space? You might think that launching objects into space is the only way to get equipment or tools to astronauts, but that's not the case anymore. The marvels of technology have brought us a new solution: 3D printing. But it's not as simple as packing up your home 3D printer and sending it to the moon. The process of 3D printing in space is a complex and fascinating one, featuring unique challenges and incredible innovations. In the vast expanse of space, the usual rules don't apply. The most significant difference is the lack of gravity, or what we call microgravity. Microgravity can make 3D printing an uphill battle. Imagine trying to build a sandcastle in water. As soon as you start building, the sand drifts away, refusing to stay put. Similarly, in microgravity, the printed layers could float away before they have a chance to solidify. This is where specialized 3D printers come in. These printers are designed to function in the unique conditions of space. They use a process called extrusion-based deposition, which works much like a hot glue gun. A filament of plastic, metal, or other materials is heated until it melts. The printer then extrudes this molten material layer by layer to build the object. The layers bond together as they cool down, creating a solid, three-dimensional object. One such printer is already hard at work on the International Space Station. This printer, developed by Made in Space, created the first ever 3D printed object off the Earth. It's a small ratchet wrench, but the implications are enormous. This technology allows astronauts to create tools and parts on demand, reducing the need for costly and time-consuming resupply missions from Earth. But it's not just about making tools. Researchers are exploring the potential of 3D printing for more ambitious projects. Imagine printing entire structures in space like habitats or fuel depots. Or consider the possibility of using lunar soil or Martian regolith to print structures on other planets. This is the concept of in situ resource utilization, using the resources available in space to support human exploration and colonization. So what does this mean for the future of space exploration? It means that we're not limited by what we can carry on a rocket. We can start to imagine a future where we can manufacture what we need, when we need it, right where we are. It's a future where astronauts can be more self-sufficient, and where we can build and maintain structures in space without relying on constant resupply from Earth. With these specialized 3D printers, we can start to unlock the potential for large-scale manufacturing in space. This isn't just about making life easier for astronauts. It's about revolutionizing the way we approach space exploration and opening up a whole new world of possibilities. The future of 3D printing in space is not just about overcoming logistical challenges, but about expanding the possibilities of what we can achieve. Imagine, if you will, a future where astronauts on a mission to Mars need a crucial tool, but they've left it behind. That's not a problem anymore. They simply print it. Or consider a scenario where a lunar base needs a new habitat module. Rather than waiting for the next costly and time-consuming supply mission, they print it right there on the moon. That's the future we're heading towards with 3D printing in space. It's not science fiction, it's science fact. NASA and other space agencies around the world are already experimenting with 3D printing in microgravity, and the results are promising. One of the most transformative applications of 3D printing in space is the construction of habitats and other structures on the Moon, Mars, or other celestial bodies. This would be a game changer, allowing us to establish permanent settlements beyond Earth. Imagine printing an entire moon base layer by layer, using the moon's own regolith as raw material. But that's not all. The potential of 3D printing in space goes beyond just structures. We could also print tools, equipment, and even spare parts on demand, eliminating the need for costly and space-consuming inventory. And we're not stopping at inanimate objects. Scientists are exploring the possibility of 3D printing food for astronauts, which could revolutionize long-duration space travel. Even more exciting is the prospect of printing biological materials, such as human tissue. This could potentially allow us to perform medical procedures in space that were previously unthinkable. The future of 3D printing in space is boundless, limited only by our imagination. As we continue to push the boundaries of this technology, we are also pushing the boundaries of what is possible in space. As we push the boundaries of what is possible with 3D printing, we are also pushing the boundaries of what is possible in space. The potential of 3D printing to revolutionize space manufacturing is only just beginning to be realized. We've embarked on a journey through the evolution of 3D printing, witnessing its transformative power. This technology, once a realm of science fiction, is now playing an integral role in space exploration and manufacturing. From creating vital components for spacecraft to building entire habitats on other planets, 3D printing is breaking barriers and expanding horizons. We've also glimpsed into the future, where the full potential of 3D printing in space is yet to be unleashed. Imagine a world where space explorers can print their tools, equipment, and even food, right there in the cosmos. The possibilities are as limitless as space itself. As we continue to explore the final frontier, 3D printing will undoubtedly play a crucial role in shaping the future of space manufacturing. The new era of space exploration is not light years away, it's already upon us.